Welcome to the Air Quality Monthly Lecture Series. Today we are having a 10th lecture. So Air Quality Management Lecture Series started in October 2020. And this lecture series is first of its kind in India, which serves an important forum for young researchers, scientists, engineers, educators, and practitioners to learn the latest advancement in theories, technologies, applications in the area of air quality management. The Air Quality Management Lecture Series is jointly organized by Indian Institute of Technology, IIT Madras, then GCRF, Clean Environment and Planetary Health in Asia, sponsored by UKHRI, and Indian International Conference on Air Quality Management. So we have, eminent speakers who gave all the previous lectures. We started this lecture with B. Sengupta, and the recent lecture given by Prasad Modak is Professor Dr. He is an executive president of Environmental Management Center in Mumbai. So today we have an interesting personality with Professor Kraichat Tantrakarnapa. So he will going to talk about system approach for air quality problems in Thailand, a case study of Haze episode. And Professor Kraichat also one of the prominent our CEPHA network partner. With this, I will now request Gopika to introduce Professor Kraichat.
Thank you, sir. A very good afternoon to everyone. It is my pleasure to introduce the speaker for the day, Professor Kraichat. He has over 25 years of experience in many natural resources and environmental areas in Thailand and neighboring countries. He has also participated as consulting unit for many organizations, both local and international. In addition, he has experience in advising students in many universities in Thailand and providing special lectures on various topics in many universities. He has experience in multiple studies and investigations such as environmental health, sanitation among migrants, chemicals usage and health risk among farmers, health risk from reused or recycled water, GHG inventory from industrial process sectors, etc., supported by multiple organizations like IOM, WHO, JICA, ONEP, and numerous others. He has vast experience in air quality dispersion modeling, noise modeling, and hazard modeling through various projects in Thailand and neighboring countries. Today's talk is titled System Approach for Air Quality Problem in Thailand, a case study of Haze episode, where he'll be discussing the Haze episodes in Thailand, its influencing factors, impacts on society, economy, and health, as well as system approach as a potential mitigation measure. Sir, we welcome you for the talk.
Yeah. So now over to Dr. Professor Kraichat.
Okay, thank you very much for your introductions about my background. Thank you very much. Let me start my sharing the PowerPoint first. Okay, good afternoon again, everyone. This is my topic. Hope you can see my slide, right? It's clear.
Okay. Yes, Professor Kraichat, it's clear.
Yeah. I would like to share my experience from my research project and from Thailand. As I mentioned from my topic, a systematic approach for haze problem in Thailand. When I use the word haze, it might be different from the context of each country. In Thailand, for the haze, we define this definition as the day of pollutions. In case of particulate matters or some gases. Right now in Thailand, we use the haze in case of the day if we monitor or we measure the particulate matters of PM10 or PM2.5, and we found that the concentration is over the limit or national ambient air quality standard, then we determine that is the haze day. And in the past, we used the PM10 because in the past we could not detect PM 2.5. We start to measure PM 2.5 in 2011. And then from that year, we use PM 2.5 to determine the haze episode. For PM 2.5, our standard is 120 ppm of microgram per cubic meter. If on that day we found the concentration is over 120 ppm, that means it's a haze day. Okay, this is outline of my talk. Start from haze situation in Thailand, where is the place, and the second thing, what are the causes linked to haze situation or haze episode in Thailand, and the third topic are the public health effects and why we concerned about this one, including not only health, but we also concerned about socio-economics in our country. Yeah, for the last topic is the system approach for problem solving. Okay, let me go to the next slide. Yeah. Yes. Why do we concern about this one? Every year we have faced the haze episode, particularly in the north and also the south. But in the north and the south, it occurs in different period of time. In the north, we found the haze episode in the period of transition from the winter to summer period. When I said winter in Thailand, it might be different from the West country like America or Canada, because winter in Thailand, the temperature might be not too cold, maybe only 20 degrees Celsius of average, or maybe 15 degrees Celsius only. But we call it winter seasons in the north. It's a transition from winter to summer. But in the south, we found the haze episode in different period. Is it in rainy season in Thailand? Why I focus only two regions? Because for other regions, we found that there are small problems compared to the north and the south. Then the north is the most critical of air pollution or haze in our country. Yeah, this is why I mentioned about the north and also focus on upper north of Thailand. Yeah, you can see here is upper north of Thailand, comprised of 8 provinces. I'm sorry, it's in Thai, the name of each province. You can see from my slide that we try to prevent our people from the haze episode because they have to be there and exposed to air pollution. You can see in the upper photo, most of the people, they have to wear the mask. And you can see the photo is not clear. It's blur from the haze because we found the high concentration of particulate matters. And we have many activity. You can see from the second photo, we request the volunteer like villagers or volunteer from other sectors to support us to control the forest fire, particularly in the mountainous area. And you can see right at the mountain part of our country, you can see the smoke like this. Every year we have been facing this situation, and then it might impact to our people, particularly children or young generation. This is our concern. And from the evidence, our government has started to monitor the air quality in our country. You can see from this map, we try to install air quality monitoring station for the whole country, but under the limitation of the budget and also the equipment, we can allocate the budget only in some part. You can see we have a station in the north, in the central region like Bangkok, and some small station in southern part, and only a few in northeastern part on the right side. You can see on the right side connect to Laos PDR. And for each station, normally we measure the common parameter like carbon monoxide, the ozone, the sulfur dioxide, oxide of nitrogen, and also particulate matter, both THP, PM10, and so PM2.5. And right now, some station we try to install PM1. That also very critical for our health because it can be penetrate to our respiratory system and finally to our lung. And this is, you can see from the map, we have a lack some data from northeastern part. But right now, our government understand the situation. We try to add more permanent station. I heard that there might be 2 or 3 stations in northeastern part, and some station in the western connect to Myanmar. This is the situation why we have to monitor, regularly monitor for air quality, because it might be a good evidence or scientific information to support our government to understand situation, not only from the photo, but we have scientific information to report to indicate that, oh, it's quite serious for our country in terms of air quality, and also consequence of the impact like economics, social, and the health impact. Okay, let me show some province in the northern part of Thailand. I focus in upper north. You can see. Yeah, you can see. Hello, everyone. You can see my slide, right?
Yes, Professor. We can see.
Okay, yep. Okay, I'm not sure. From this photo, I select Chiang Mai. For Chiang Mai, it can be said that like a capital province of northern part of Thailand is quite big. Maybe second rank from Bangkok, a capital of Thailand. And the Chiang Mai province, you can see from topographic map, is a mountainous area. And in the city is a flat terrain, but the surrounding is mountainous areas you can see from the map. And from the right side, I show the graph. The graph represents for PM10 concentration, because at that time we have a limitation, we can measure the PM10. But now from 2015, we have a data from PM2.5. And you can see the pattern of PM10 from 2008 until 2014. The pattern for each year, you can see a similar. We found the peak, like in 2010, oh, the peak is quite high, close to 300 microgram per cubic meter for PM10 concentration. And for the other years, you can see the similar pattern, but in 2011, we could not see the peak in this year. The reasons behind of this is the big flooding in our country in 2011. Yeah, you can see from the history of our country, we have a devastating flood in 2011 for the whole country. I think more than 50% of provinces we have been facing the flooding, and the rainy or precipitation or moisture content in the air might be influence factor linked to PM10 concentrations. Okay, let me show for the other city. Yeah, too. And in this one, I collect from the 2013 and 2014. You can see the pattern of PM10 concentration in Chiang Mai is similar. We found high concentration start from maybe the end of February, March until April. Similar pattern in both years in this province. And also, I would like to show another province connect to Chiang Mai. This province is connect to Chiang Mai and also connect to our neighboring countries. In the west is Myanmar, and on the right side, connect to Laos, PDR, and upper in the north direction is connect to China. You can see the topography map of this province is mountainous area with small fraction of flat terrain. And for PM10 concentration in this province, I think you can observe that it's a similar pattern of PM10 concentration compared to Chiang Mai province from the previous slide. But we also have the early, maybe a small day, number of day that over the limit of 120 ppm of PM10 in 2011. But for the other year, you can see over the limit of the standard. And okay, yeah, you can see if we consider in 2013 and 2014, you can observe the high concentration of peak of PM10 in March and April. But compared to both year, the concentration in 2014 is more lower than, it's slightly lower than 2013. And the questions from the graph or from the history, I have a question: why we found the Haze episode only in this period? Since we have similar activity like the traffic volumes or industry activities or human activity in the society is similar for each month or each day, but we found the episodes only in this period. It might be some influence factor from the climate or weather parameters. And this another one, then I select maybe not connect to our borderlines because Chiang Mai and Chiang Rai is connect to the borderline of Myanmar and also Laos. But this province is in the middle of the northern part of Thailand. We call Lamphun province, but the topography is similar with mountainous area and small fraction of flat terrain. We also found similar pattern of PM10 concentration is over limit, particularly in 2011 compared to both provinces. We found this year high concentration of PM10 and over the standard of our government. And when we consider this one, we would like to see in details for like the day, a time of each day, a day of each week, and the month of each year. You can see from this graph for the period of time in a day, we found the peak in this province in the evening of each day. You can see from this graph. And when we consider for the month, you can see we found high concentration in February and the peak in March and slightly lower in April and sharp decrease in May, June, and July because it's rainy seasons in this region or this province. And if we consider the day for each week, you can see some day we found a small peak in the morning, but mostly we found the peak of high concentration in the evening. That is very interesting for us. What are the influence factor for high concentration of PM10 in this period only, not in other period? One thing that I consider it might be from the monsoon. The monsoons in Thailand, we classify the monsoon into two categories. The first one is northeast monsoon, start from November to January, and some years it's February. And the second is southwest monsoon from May to October. And during the two monsoon, we have the transitions period. Like in the north, we found that the transition period from northeast to southwest monsoon is start from February, May, March, and end at April is the period, and we found high concentration of PM10 as I showed you before from previous slide. This is also very interesting. Our findings that it might be influence factors. And when we consider for the air quality calendar, you can see I classify the concentration, daily concentrations for each day in 2013, 2014 in these two provinces. You can see we found the orange and red colors in March and April. I used the red and orange color to determine, because we use this one as index, we call air quality index to our people. And when we talk to the people, or we just say, okay, PM10 over the limit 120 ppm or microgram per cubic meter, might be quite difficult to communicate to them to understand the point. And then we use the color to classify if the villager or the people saw the color in red or in orange. That means, oh, it's quite serious for our health, because the air concentration of PM10 or PM2.5 right now over the standard. For our standard, the pollution control government is the organization to take care, to handle, to measure the air quality for each province. You can see we have a criteria to determine. We can use PM10, PM2.5, or other gases to determine air quality index. If PM10 over 180 microgram per cubic meters in our country, we classify as, oh, it's dangerous for our people, for our health. And for orange, it will be impact to our health. For the yellow, is moderate. It might be impact for vulnerable group. I use the vulnerable group might be like babies, children, pregnant women, or elderly people. And you can see similar pattern in two provinces, and also in similar pattern in March and April in both years. And for another province that I showed you before is Lamphun. Lamphun is in the middle of northern part of Thailand. You can see it might be slightly different from both two provinces. We found yellow, we found orange, and someday we found a red in February. Right? You can see it's quite different from both provinces. But however, we will also found high concentration in March and April. You can observe from the color, red color in March for both years. And when I consider the influence factor, I think meteorological variable might be the factors cause the impact to air quality in the upper north of Thailand, in these three provinces. Then I use the data from NOAA. We use high-speed model to see the trajectory. We can observe during the Haze episode, the wind blow from our neighboring countries from southwest direction for three provinces. You can see the green in Chiang Rai, and blue one for Chiang Mai, and the red color is for Lamphun province. For 4 days that we have a problem of Haze episode, we found most direction of wind blow from southwest direction. That means blow from our neighboring countries. Then I consider for another period like this one, from 15 April in 2013. On 15 in this province, we found, oh, it's green color. Then I would like to see how about the wind direction. We found the wind blow from southeast direction. That means blow in our country, within our country. This is also very interesting. And from these findings, I have a hypothesis from this that it might be from transboundary effect, wind blow from our neighboring country and cause the Haze episode in the province, in the area, particularly in the province as a borderline connect to our neighboring countries. And this is the from other research paper. You can see they classify the cluster of wind direction from a trajectory model. You can see the majority of wind blow from southwest direction because we have about 9 months of southwest monsoon. 67% you can see the cluster of wind blow from southwest direction, but a small fraction maybe wind blow from the east. And you can see this is my hypothesis because it might be from transboundary. You can see from the wind loss, the majority of wind blow from southwest direction from according to southwest monsoon because it takes about 9 months compared to northeast monsoon direction only 2 or 3 months. Okay, let's see. As I mentioned, what are the potential sources of air pollution in the upper north of Thailand? You can see from this graph, from the paper. This is from our colleagues, Professor Kim Oon from AIT, also investigate the source of air pollution. You can see it might be from the traffic, because we use the petroleum, we use the gasoline or fuel to move the vehicles. It might be from the forest fire. It might be from the agricultural residue burning. Like you can see from the photo, we have the mountainous area with the plantations of maize or some species, and after harvesting, the farmer prefer to burn it because it's quite easy and simple for them, and then they can save the money to take care of their farm. And also it might be from tobacco because in the north of Thailand we have some area for tobacco planting. And not only that, we also found the biomass burning from forest, like forest fire, or maybe biomass burning from solid waste management in some village or some cities that we cannot support, we cannot provide the proper waste management or security landfill or the landfill in that areas. And that's also the harvesting of plant like rice. Some area we have the second rice plantations. Then after the harvesting, they also burn the residue from their farm, and we observe the concentrations is high in March, and you can see from the colors of each source, like from tobacco or from biomass or from the harvesting. Yeah. And other source might be potential source also from human activities, because in the rural area, most of people in the village, they use a wood and the charcoal for their cooking. Some house, they use the charcoal for burning as a cooking fuel. In addition, from that field in Lampang province, you can see from the graph, the highest concentration in this graph is Lampang province. Lampang is the province of the power plant city because they use the lignite as a raw material for generating electricity. And for the lignite, they also dig or bury from their own in the city of Lampang. It's a big mining of lignite in the countries, including the power plant is the biggest one, I think, in Thailand. We burn the lignite and it causes the particulate metals and also some gases like sulfur dioxide particularly in the past, because in the past we did not employ or mitigation or control the emissions of gases and particulate matters. In addition, from the mining or power plant, from the household burning, traffic also one problem, because in the north, as I mentioned, Chiang Mai is the second rank of city in Thailand in terms of populations and also business activities. There are many traffic similar to Bangkok. It might be from the traffic emissions that cause the impact to air pollution, particularly PM10 or PM2.5. Okay, then from the evidence, from the history or from the statistic of record about air quality, we also concerned about our people health. As you know, from air quality index, this is from the record in 2008 to 2014, the index of air quality we found, even though it is some part over the limit of air quality in terms of color, you can see we found the red color, we found orange color. That means over the limit of national ambient air quality standard in Chiang Mai. Also, Chiang Mai, the red color in Chiang Mai much higher than in Chiang Mai. I mean, the percentage of excess from national ambient quality standard PM10. And we concern this one because you can see from the lower part, we have a photo of PM10 and PM2.5. You can compare the size of PM2.5 and PM10 to the size of your hand, right? It's a small fraction from the hair. This is the common hair for a human hair. Very small fraction that we cannot see from your eye, right? And then it might be penetrate to our respiratory system and then to our lower part like lung in our body. This is why we have to concern this one for our people health. And then this is from the data that we try to plot from PM10 concentration and number of patients. You can see the red color is number of respiratory disease pattern that go to the hospital. The pattern of the patients, you can see is the consequence from the episode of Haze of PM10. After we have episode PM10, we found the case of patients according to respiratory disease in the hospital. And this is from the data from Ministry of Public Health, Department of the Disease Control. We have of information during the Haze period. You can observe from each province number of cases of all respiratory disease during the Haze episode in northern part of Thailand compared to, this is the incident rate per 100,000 of populations. It's quite high compared to other regions of Thailand. This is we concern. And this the study from some professor in Thailand mentioned the linkage of our acuity index and our respiratory disease in patient. They have to go to the hospital, and you can see this is the simple linear regression. You can see the linkage with the p-values. You can see from the scatter diagram during 2010 and 2011. And this is another one in 2010, 2011 also, about the linkage of the PM10 and lower respiratory disease. Yeah, this is also similar. We have the air quality index, and we try to see the association with air quality index. We found the association you can observe. The R correlation coefficient is 0.36. Yeah, that means the association is quite is moderate level. It might be the linkage. This is only a simple equation, but it might be some factors that we could not include in this equation. Okay, from my interest, when we consider the Haze episodes, then we have to understand the situation. Where are the source of haze? From this diagram, you can see the source of haze. It might be from the forest fires, like hotspot, or maybe from human activities, like anthropogenics, like from the city or from the rural area, maybe from the traffic transportation, maybe from industry construction activities, household activity, and also from the forest fire that from the natures, because as I mentioned you before about the mountainous area, we have the maize plantation or other species or other plantation. It might be linked to land use or land cover. It's a different meaning for land use and land cover, because sometimes Department of Land determine, okay, this land is the agricultural area or paddy field, but only in the rainy season. We cannot do paddy field or rice plantation in summer period. It will be dry. Then the land cover is changed from the green to be a dry areas. This is very interesting because we found the episode in the dry period. And another factor, it might be from climatological factors. During the rainy period, we could not see any haze episode in the upper north or other regions of Thailand. And also the transition period and also dry period. This is the concern, the factors that might induce the haze episode in our countries. After we have episode of haze, what will be happened? It change our environmental conditions, air quality, and from the environmental change, it will induce the impact to our society. Like, the business in the upper north of Thailand, the tourists, they have the impact from that, because many tourists just say that, oh, it's quite critical. I concern my health. I cancel my flight. I cancel my tour, my program to your city, because it's quite difficult for me to travel that, because I concern my family member to be there to export for activities. That they're concerned about the health impact. Then the tourist activity and also service activity, business, they have a problem in terms of economics from haze. And another thing is health problems, because the people, local people, they export to that, right? Cause impact, because they have to spend a lot of money to control the haze. And in addition from that, the people, they have to pay their money for hospitalizations. This is very our concern. And in addition from that, we have more impacts linked to the haze, not only from the economics and also the health. For the health, we also concerned about physical health, but mental health also is very important for our people. And our government has to invest the money a lot to protect our people in terms of health, and also try to control the emissions and control the concentration of the particulate matters. Then from the past, we try to respond to what the haze problem in the regions. You can see this is the mitigation measures that we try to control the haze or the problem. Many approaches that we use from the past. We use like local wisdom. You can see on the left side, the left photo, many voluntary from village try to support the government to control the forest fire. We create the buffer zone. I use the buffer zone to separate the dry area from the forest. You can see if we have the forest fire, we can control the boundary of the forest fire. And we also use many equipment to control the fires. You can see from the photo. This is a local wisdom book, local equipment that we use. In addition from that, we also use artificial rain. I use the artificial rain is the theory. This is the belong to our late King Ramana, right, who invent this innovation. We capture the clouds, and we put something to generate the cloud, and that induce the rain in some area that we can produce the artificial rain to control the haze in the regions. And in addition from that, you can see many municipalities try to spray the water in the city to control the haze problems, particulate matter, but it's quite difficult to control because we use a lot of money. And during the dry period, we have limitations of water because some area is dry. We have a shortage of water source. Also, this is also quite difficult for some municipality or some area. Then from our experience, this is our approach. As I said, a system approach. We integrate many approach to solve the haze problem in upper north of Thailand. Since we try to analyze the source, as I mentioned about the agricultural, also one source of the haze or particulate matter concentrations, the agriculturals in upper north, we call it depends on some like the capitals. I use the word supply chain because the villagers, they can do some agricultural that we call dependent agricultures. Some of you might confuse what is it? Dependent agriculture. Dependent agricultures, that means farmer, they did not invest their own money. There might be some private sector just provide the budget for them, support them by the money, support them for raw material, their seed and fertilizers, pesticides, and some machines, and some budget for farmer to conduct, to operate their farm. The farmer use only their task force or their workforce to control or to operate their farm. And after the plantation, they got the products, they harvest the products, and then finally the private sector, they go to the farmer, they get the products from them. The farmer also earn the money from that. That I say dependence agricultures. And then we have to talk to communities about the haze resilient community, because we have to adapt from the haze situation. In terms of we cannot minimize the impact. We have to provide the information to the people in their village. How can we adapt our daily activities? For example, is it possible to change from some plantation to be the others plantations, or is it possible we can provide the comfort room during the haze episode, because we have the vulnerable group like elderly people. If we concerned about their health, their house, they cannot prevent the haze or the particulate matters entering to their house. The concentration of air quality might be high, I mean the indoor air qualities. Then is it possible for municipality or organization to provide the comfort room for villagers, particularly vulnerable group? And the third one, we also concerned, how can we warn our people, because we cannot predict the haze, right? Tomorrow there will be the haze or not? Next week there will be the haze or not? Then the third approach is we try to develop the dispersion model to see or to forecast the concentration of haze or PM10 or PM2.5 in the regions. And then from the prediction model, we can inform our people as warning system, people that, okay, for next week or tomorrow or the day after tomorrow, it might be high concentration. Then you try to prevent yourself before you going out. You have to wear the mask to prevent PM10 concentration. Or is it possible to stay in the comfort zone, like in the health center, some area that are provided from the local organizations? This is the third approach. And then not only for monitoring monitoring approach, important one is monitoring system, because we cannot provide monitoring station for every village or every communities or district. As I showed you before, we can provide only one station in one province, okay, except for some province like in Chiang Mai, we have 2 stations. In Lampang, we have 4 stations because we have power plant there, we have the mining facility there. We have 4 monitoring stations. This is important to make sure that this is the real information. Right now, we have many stations because we develop we call the sensor according to the collaboration, innovation, and also research team among the university and organization. Right now, we install, I think, more than 500 the sensor station to monitor PM10, PM2.5 in the regions. And this one important thing, we need to calibrate our equipment to make sure that our measure, our monitor data can be informed as a warning system. This is very important. We need to monitor to ensure it can be used to report to organization and also to publish to villages or interested people. This is very important. And then the last one is capacity building, because many people still misunderstood about the Haze problems in our countries, in particular in upper north of Thailand. Then it's very important we focus on how can we distribute the knowledge, educate the villagers in rural area, and we focus not only from villages. Right now we extend our project to strengthen to our young generation. We create a youth a group to understand situation, because young generation will be the adult or people to take care our society, our environment. This is the defined approach from our project that we got the funding from National Research Council of Thailand under the collaboration we call Research University Network, or a short name we call RUN. We start from 5 university, work together, but right now it's extend from 5 to be 9, and currently it's extend to be, I think, more than 15 university and academic institute or research organization work together to solve this problem under the FRIE project or FRIE approach from this slide. For the supply chain, you see, we try to inform the local people. This is possible to to do some plantation in different varieties, not only one crop or monocrop like the maize. And then we try to educate them how can we change the residue. You see, from the maize in the past, we just only burn the stem and the maize, the corn or the maize like this. Now we try to initiate a project to get the benefit from this to make a charcoal, because as I showed you before, the local people use the charcoal as the fuel for cooking. Then this is example, we educate our villager, we change or we transform from this from the burning to be a charcoal. like the cotton, we have a project to transform the cotton to be the fabric, and we can change this one to be the useful thing like a bag. Many right now we have many products from the fabric of the cotton or the rice. We try to change or transform the rice product to be many products right now. This is the supply chain to change from the monocrop to be the variety of plantation in particular in the mountainous area. And for the second, the haze resilience, we develop many technology equipment, and some, some district or some sub-district, we install the computer for local people. We educate them how to do, and we can get information from them because they live in local area, villages. In village, and they can provide information for us by different approach. We have many health volunteer to support us. How can we control? We have to talk to them how to adapt our daily activity for the haze period. This is the second approach. And this is the third one, as I mentioned. I am the one of PI of this project with my colleagues from other university. We developed the dispersion model. You can see the movement of concentration of PM10, and then we can inform our villages, our local organization to see, and we can predict and we can inform them. And we also have application from smartphone. Even though you cannot connect to the internet by computer, but you can use from applications to see. You can see, okay, now I live in my home. I can see, okay, how about the concentration of PM2.5, PM10 right now, and how about tomorrow? We can predict for 3 days, and people can see the situation, and they can prevent themselves and inform their relatives or their friends or villagers about the situations as a warning system. And then this is the monitoring. As I mentioned, we have many monitoring stations right now, both permanent and also temporary stations. This is in Upper North. We also have the innovation for the sensor equipment to monitor, and everyone can see from the smartphone right now. You can connect to the if you can connect to internet. And also in villages, we can show information to them, like in the center of village, because we install the sensor equipment for them to see. If they pass to that area, they can take a look. Oh, how about the situation of haze, about PM10 concentration or PM2.5 concentration in our village. They can understand and inform their friends there. And this capacity building, we try to provide many projects like curriculum for young generation, distribute knowledge, and try to encourage them. It is possible to change the areas from the maize plantation to be other species plantations. Try to change. You can see from these photos. Right? We change from this to be the green area like this. We need the collaboration from villagers and also local organization. We understand we need more time to transform or to change their understanding and their perception and their collaboration with us. And not only from our approach, as I mentioned you before, because from our finding, our assumption, it might be from transboundary effect from the regions. And I have a chance to share experience and knowledge and our scientific information to our neighboring countries. I have a chance to travel to Myanmar, the borderline of countries, to provide information to them. Some association and organization, we have a chance to share in Cambodia also. We have a chance to share our findings in Laos PDR to show information to them and try to have collaboration and linkage amongst the countries. But we also have a limitation because international regulation or laws. We need some support from our government and also our neighboring country government to take a look to understand. And a very important one is we need more research to find the evidence to support the government and our neighboring country government, particularly the linkage of aggressions and also health problems. This is very important of agreements. You can see from this, it is one meeting. This is agreement among the countries in Southeast Asia country. That is also the most effect of air pollution in the regions from the WHO informations. Yeah, I would like to finish my lecture or my presentation right now. Okay, it will be very appreciate if you can share your experience or discuss about the haze situation or haze problem in your own countries, even though in Thailand. Okay, I would like to stop my presentation. Thank you everyone for attending my presentations.
Yeah, thank you very much, Professor Kraichat. It was a very interesting and wonderful talk. We will just wait for some questions. And meantime, I would like to know, maybe we'll just give some time for everybody. So maybe we'll ask everybody, can we all start your video so that we'll have a one picture with Professor Kraichat, and then after that we'll start looking for some questions. So meantime, please use chat box to type your question. Yes, all of you just start your video, so we'll have one photo with Professor Kraichat.
Okay. You have to count, right?
Yes, there are so many people, and yeah, hope Gopika and Dheeraj, will you able to plan the photograph?
Yes, sir.
Yeah, okay. So let's see, everybody has started their video, and I'm not able to see them. Everyone.
Participants, they're not able to see participants in the grid, sir.
Okay, why? Is it they were not allowed?
Because of the panelists.
Okay, we can't see them.
I'm just checking some options if it is available, sir.
Okay. Okay, we'll take one photo and then we will take others. Maybe by
Yes,
then
sir.
we'll start the questions now. Yeah, maybe with this we'll take one photo. So Professor Kraichat, you can, yeah, he's already started his video. So maybe you can just take one quick question. Maybe the photo. Okay, done?
Yes, sir. Yes, sir.
Yeah, Professor Kraichat, there is a question for you. How air quality management relates to environmental impact assessment. So it's a question, how air quality management relates to environmental impact assessment.
Yes, okay. You know, from the environmental impact assessment, when we consider the environment, air quality is one aspect of physical environment, right? And then it might be impact of air quality from human activities. Like if we propose one project, we have to conduct EIA or environmental impact assessment in our country. It's regulations. And air quality is the consequence of the proposed project or human activities. we need to concern, like for accuracy assessment, if high concentrations of our concern, like particulate matters concentration or some gases, it will link or cause the health problems to our people because we have to export from accuracy. Then we need to provide mitigation measures, right? If we understand the source or the problems, we can provide mitigation measures to prevent environmental degradation from accuracies or from the project, including the health of our people, right?
Okay. There's another question. What significant reduction changes observed during the pandemic time?
Oh, what the significant change that we can observe during the pandemic time? You mean pandemic time, not linked to the COVID, right? But that's in the pandemic time.
Yeah.
I'm not sure.
Yeah. So did you notice any significant changes with air quality improvement during the pandemic?
Pandemic of COVID-19, right?
Yes, yes.
Okay. Yes, right. Because from the COVID pandemic, we found, from my observation, and I asked information from Bangkok Metropolitan, also pollution control, we found accuracy better compared to like 2019 or 2018. I have information like in Bangkok, when I compare particulate matter PM 2.5, PM 10, or other gases, we found is smaller, I mean concentration compared to 2018. In the year of 2020, or even though in this year 2021, smaller, much smaller, because you can imagine, because the traffic is much more smaller. We have a lockdown, we have a curfew, many industry they have to close, many private sector they have to close, and people also employee they move from the city to rural area to their hometown. This is a factor might be influence factor and cause the reduction of accuracies in terms of concentration. Yeah.
There's another question. According to you, what was the main reason for Haze in those areas of the study? What is the reason for the Haze in that particular area?
What are the main reasons for the haze? Oh,
yeah.
Before I study, I focus on the north. I have information. I asked information from pollution control department about accuracy information, and analyzed. We found high concentration in the north. Then I focus in that area, and in addition from that, I also observe the health data, the incidence rate of that the disease, the link to accuracy, like respiratory disease, both upper and lower respiratory disease or cardiovascular disease, including lung cancer. We found high incidence in that area. This is the reason that's why I focus on that.
Okay. The other question is how much scope is there for transboundary air pollution control treaties between countries? This is a
very interesting information.
question.
Because from my study, I try to see, because particulate matter like PM10, PM2.5, we cannot see with our eye, and then a small fraction it can be dispersed according to the wind, and might be dispersed far away from the source. I cannot figure 100 kilometers or 10 kilometers, quite difficult. You can observe that from information from like in China, you can see the sandstorm from the western part, right, to Beijing, right, in the China. That means the distance is quite far away from Beijing, but we can observe. And this is very interesting question to me, that, okay, how can we classify the transboundary from that? Then I use the days. It might be during the 5 days from trajectory backward from Haze episode, and to see backward from 5 days to 7 days of wind blow from that directions or not. This is my criteria. I use the day trajectory study. Yeah.
This is another interesting question. What pollutants are mainly responsible for the air pollution due to forest fires? So in the agriculture fire or forest fire, if happens, are there any particular pollutants responsible for the air pollution in a particular city or area?
Okay, because the forest fire is a biomass burning, and when our government monitor the particulate matters like PM 2.5, PM 10, but inside PM particulate matters, in terms of scientists, we need to know more about the details of particulate matters. It might be some metals, right, inside the particulate matters. It might be PAH, polycyclic aromatic hydrocarbons. Yeah, from that, because of my biomass burning, from my literature review, we found many pH or metals in particulate matters in many countries. And then after that, we also collect the filter, the dust or particulate matters. We try to analyze the metals and also polycyclic aromatic hydrocarbon, because some of them might induce the carcinogens, right? It might induce the cancer, particularly lung cancer that I mentioned. We found the linkage of lung cancer and also air quality. And we also found like benzoyl in particulate matters. Yeah, this is our concern. Yeah, there are many pollutants there. We need to investigate more in details.
Okay.
Yep.
Yeah. So there's another question. Can you explain which factor contributes maximum towards air pollution? Is it meteorology or air pollution sources?
Yeah, this is from my findings. We found meteorological is key roles in that region, because we found the episode only in the transition of cold season to be dry season period. But in other period, like rainy seasons, we found a small concentration compared to a dry season. That means meteorological is a key role for pollution there, but not only all, not only 100%, but it depends on human activities also. Yeah.
Yeah. So there's one last question. How the infrastructure and building contribute to dispersion and deposition of pollutants in urban areas?
Yes, sure. I have another project, but I didn't show in my presentation. We collect the samples like PM in Bangkok with high delivering, because it's urban in the city. You can imagine about the characteristic of Bangkok. It's a mega cities. We found the obstruction of building induce the movement of particulate matter of air pollution in Bangkok. That's very is a key role, because in Bangkok it's quite different from rural area, because with their high buildings, the infrastructures also induce and change the concentrations also. Yeah.
So there's two more questions have popped up now. So does the ozone also contributes to haze?
Pardon?
Ozone.
Yes. From I didn't show from my presentations. From my findings, we found after the PM concentrations, we found the ozone concentration is quite high after the particulate matter concentrations as a daily observations. Yes, it links to the particulate matters, and we need to right now. We also consider the ozone, because number of concentration is quite increasing, particularly in vicinity of Bangkok, particularly in the, I think, northeast and the north direction of Bangkok. We found high concentration of ozone. Right.
Okay. So what mitigation measures can be adapted to reduce this, particularly this large-scale air pollution?
Yeah, then we need to minimize the source. We try to need the support, like collaboration from industrial sectors, from agricultural sector, from villagers. That is it possible? And from the upper north of Thailand, every province we have a regulation. You cannot burn right? A residue from your farm for 30 days, for 60 days during the dry period or summer period. These are local regulations, these mitigation measures, right?
There is another question. In Bangkok, also in Thailand, there are many fertilizer industries, particularly the
Yes.
pesticides. These are things that might be coming out. How they are affecting the air pollution? What is the role they played, the emission from these industries?
For pesticide or fertilizers, most of the farmer they use it for their farm. And this, I mentioned why we concerned about the metals or some substance that contain in our particulate matters. We also analyze something like the metals that might be induced from or generate from pesticides or fertilizers. I think it also plays roles in air quality or air pollution in our country. We need to investigate more because from our monitoring, we monitor it, we found the contaminant of that, but we need to do more research to see the distribution or the linkage of fertilizer used in each area, and we can see the level of air pollution. We need to do more investigations. Yeah, but I do believe we have association of pesticide or fertilizer uses and also the air quality.
Yeah. Thank you, Professor Kraichat. I think it was a wonderful. I think the talk was given a lot of informations, particularly in the forest fire related air pollution. He also suggested the kind of technology that are adapted in order to minimize some of this, pollutions in a large scale. I request Dr. Madhusudan to summarize the talk and conclude.
So, good afternoon, everybody. Thank you, Professor Kraichat Tantrakarnapa of Mahidol University. He has accepted our invitation last month itself. Today's lecture series, that is the series of the 10th one, he discussed about the systematic approach for haze problems in Thailand. When he discussed this issue, he focused on 4 issues. That is the haze situation in Thailand, the causes of haze situation, and the public effort, the public effects, and the system approach for solving the problem. So the talk was centered around these 4 approaches. He explained the haze situation in Thailand by giving the examples of 3 cities, that is Chiang Mai, Chiang Rai, and Lumban cities in Thailand. He also discussed about the differences of north and south situations and how the seasonal effect causes the haze situation in these cities. Further, he discussed about the causes of the haze situations, the potential haze situations basically due to burning of biomass, the tobacco activities, and domestic sources or the rice harvesting. So he explained about the issues related to all the potential sources of haze situations and causes. And then he moved towards the public effects and how the situation is looked by the Thai government. So he discussed about the air quality index, which is adopted in Thailand, how the air quality calendars were prepared by the government to educate the people in major cities. And also he explained about the standards of PM10 and PM2.5 and the different air quality indices and the health impacts, etc. So further, he has concluded with the system approach for solving the problems. So when we discussed about this system approach for solving the health impact studies and the relationships between the lung diseases, the intervention and control, and the impact of tourist economics and the environmental issues and the social impacts were discussed in details, and the mitigation strategies like control of forest fires, creating the buffer zones, and also the artificial rain. These are the points he has highlighted in discussed about the mitigation strategies. So the integrating approach of 5, this one, that is the supply chain monitoring system, dispersion models, and capacity buildings. How important these issues are there, he discussed in details. And the regional Haze efforts with the neighboring countries were discussed. The treaties with Cambodia and Myanmar were also explained. So in a nutshell, this is the approach for the haze problems in Thailand was well explained, and the professor has also interacted with the participants by answering the questions. So about around 10 questions were there in the chat box. I think the professor has answered the questions very well, and wholeheartedly on behalf of CEPHA network, thank you, Professor, for accepting and giving the wonderful lecture as this series 10. And formally, we thank all the senior professors, associated people, and colleagues from different pollution control authorities, students community, and researchers for participating this online lecture series very keenly and asking questions. Thanks are also due with the our official backup team, Dheeraj, Gopika, and Swaroop, for their excellent support and making this lecture series very fruitful. We thank our mentor and the network director, Professor Shivanagendra, for the guidance and coordination. Thank you everyone for participating the AQML lecture series 10. We shall come out with a different lecture from an eminent person in the month of in next month. Thank you everyone. One can browse the CEPHA network for all the earlier lectures and also the videos of all the previous lecture series. Thank you once again. Thank you.
Yeah, Professor Kraichat, thank you very much. Please, you have any?
Yes, you're welcome. Thank you, everyone, to join this.
Yeah, thank you. We will look forward to see you sometime to visit India once things are better.
Yes, okay. Hope to visit India. You can come to Bangkok. Hope next year, right?
Yes, we will see that one. Anyway, we are planning for a conference, so we will see. Okay.
Okay. Yeah.
Thank you very much. Thank you all for joining this lecture series. Stay safe. See you all in the next series. Bye-bye. Thank you, Dr. Masood.
Bye. Stay safe, everyone. Yeah.
Okay, so Dheeraj, I'm leaving, so you can stop the lecture. Maybe you can. Yeah.
Yes, sir.
Okay. Bye-bye.
Okay,
Thank you,
bye.
sir. Bye.